Okay, now we are going to dive into chapter 12, and this is talking about calculating medications that are used in IVs. So, the first thing that we come to is talking about the amount of solute in an IV fluid. So, IV bags are large. Um, they're usually somewhere around between 500 to 1,000 milliliters, and so can be rather large. They have other pre-mixed IV piggybacks. They call them piggybacks because they're little small, usually 50 milliliter containers that are added onto an IV. So they kind of piggyback on them. Um, so there are different kinds of IV fluids. The most common ones are here in this chart that I'm about to show you. You need to know these because they will have these abbreviations are fairly common. So you'll need to know that NS means normal saline, and normal saline is 0.9% sodium chloride. You need to know that. Then, of course, a half normal saline is going to be 0.45 sodium chloride, or half the strength. That kind of makes sense. If you see D5W or 5% DW, that means it's dextrose 5% in water. That's a type of sugar, 5% in water. D5LR, that is dextrose 5% in lactated ringers. And an RLR is a ringers lactate or lactated ringers. And those are special IV bags that have pre-mixed electrolytes. They're really good for dehydration, for burn patients. They have a special amount of sodium chloride and all these different things that are better than just saline itself, extra electrolytes. I always called them lactated ringers because that's what my doctors always called them, but they are also called ringers lactate. D5NS is dextrose 5% and 0.9 sodium chloride, or dextrose 5% in normal saline. It's the same thing. And so on and so forth. You have your D5 half NS, D2.5 half NST. And so that's the 2.5% dextrose in 0.45 sodium chloride. And then the D2.5W, and that's 2.5% dextrose in water. Okay, and that's usually sterile water. So sterile water and, of course, normal saline are two different things. So when you have a problem that mentions D5W, and that means that there's 5% dextrose available in the solvent. So you would write that, just like we learned in chapter 11, at the end, that is 5 grams of dextrose is found in 100 milliliters of fluid. That is your given. Okay, so that was your liquid to liquid, or your weight to weight, or your weight to liquid, depending on what you are doing. Okay, so let's go over to an example here. So your physician orders 500 milligrams of 5% DW, and so 5% DW is dextrose 5% in water to be given to a patient. What's the metric strength in grams of the dextrose in the bag in this bag of fluids? So it's reminding you here that 5% is 5 grams of solute of dextrose is found in 100 milliliters of water. So that's what you know. You know that you have your 5%. So you would put your 5 grams over 100 milliliters. That's your known. What your unknown is how much is in a 500 milliliter bag. So you need to find out how much dextrose is in there. So then you would solve for X. And once you cross multiply, then you'll come up with 25 grams. I like the way to set it up this way rather than this way, because it just helps me know what I'm doing when it's set up as the ratio proportion. when it's set up straight across like this, it's hard for me to interpret. So let's go to the first in practice problems A. This is on page 474. In practice problems A, it's asking for the weight of sodium chloride in this label. So your sodium chloride is 0.9% sodium chloride. How much sodium chloride is in these fluids? So I've got these flipped. So I think. Okay, I did have those answers switched, and I was totally, that was messing with my head. So the weight of sodium chloride in these fluids, so we would do that if we looked at our sodium chloride, it's 0.9, okay? We know that's 0.9 grams. We've learned that in 100 milliliters, okay? We learned that in the last chapter. That you always put over 100 milliliters. That's how much is in 100 milliliters. But we want to know how much is in 500 milliliters. Okay, so then you would do the math, you cross multiply, and you get 4.5 grams. That's how much is in as far as sodium chloride. So it's asking what the weight of dextrose is in these fluids. Well, your weight of dextrose, it's 10 grams over 100 milliliters. Okay, and we need to know how much is in 500 milliliters. These are pretty simple problems. You do the cross multiplication and you come up with 50 grams. That's how you do number 1. I will skip over, because number 2 is exactly the same. I'll skip over to number 3 and show you that this one, they're asking for a 50 milliliter IV piggyback, IVPV, IV piggyback, and it contains penicillin 1.5 million units. And your patient has gotten 35 milliliters of the medication. So with that, if we have 1.5 million, so it's 1,500,000 units, okay, that they've gotten. And it's in a 50 milliliter bag. Okay, that's what they want to get. Okay, but the patient has gotten 35 milliliters of the medication. So how much has he received? So if in 35 milliliters, how much is in 35 milliliters? You do the cross multiplication, and you get 1,050,000 units is how much they have gotten with 35 milliliters of the medication. Sorry for the blurriness. There we go. Let's see here. How about number 6? Let's check out number 6 here. The physician orders penicillin G potassium 2.4 million units to be added to 1 liter of normal saline. So you have on hand okay, so it's already been reconstituted once. So how many milliliters of medication should be added to the fluids? So what you have, is the 1 million units in 1 milliliter. Okay, that's how much you have. That's what you know. But what you want